Okay, and our next presenter is Saurabh Bagchi. And Saurabh, you ready to go?
Okay. I am.
All right, you have the floor.
Good afternoon to you all. My name is Saurabh Bagchi. I'm a faculty in electrical and computer engineering. And I'm going to tell you today about a project that we have going on looking at the aspects of resilience. This is being done under the aegis of a center that we have here called CRISP. We have a fairly diverse team in terms of technical expertise. We have people from the College of Engineering, Jitesh and Nadia. We have Anant from management, Tara from political science, Bruno from computer science, and Roberto from PCRD. So this project is looking at the aspect of resilience as it ties together the innovation infrastructure that we have and a set of physical infrastructures that we have in terms of supply chain infrastructure, transportation infrastructure, and so on. So the problem statement that we posed ourselves broadly are two of them. One is that what kind of interdependence between the innovation infrastructure, innovation ecosystem and the physical infrastructure is desirable? What kinds of interdependencies between them exist today? And further, what kinds of interdependencies can we engender between these two different kinds of infrastructures? And the point behind the interdependencies is that these interdependencies help us get our work done, but it also means that it exposes certain vulnerabilities that we have. For example, a disruption in one of these infrastructures, if left unchecked, can quite easily go in and affect the other infrastructures. So the question that we asked in this project is, what kinds of interventions can be done with the objectives of reducing these vulnerabilities so that even if one infrastructure has some disruption in it, it does not become like a house of dominoes and then the other infrastructures are also get affected by this. And we are driven by two overarching questions in this. One is that there are certainly cost constraints, economic drivers which enable us to do certain things and not do certain other things, and also sustainability is a first order principle in here. Since we had proposed this, parts of this project are already being funded through WIN on IoT resilience, Army Research Lab on battlefield resilience, embedded system security work with Sandia National Lab, and the machine learning security with Northrop Grumman. So what you have here is the innovation infrastructure and three sample physical infrastructures that we are looking at, which are susceptible to short-term disruptions like natural or man-made disasters, mid-term disruptions like technological inflection points, and long-term disruptions, environmental sustainability problems. And we are looking at what kinds of interventions can be put in individually within these infrastructures across the interdependencies between them and also in the innovation infrastructure. So here's a look down into one level of detail. So here you have an example of the manufacturing infrastructure and the transportation infrastructure. There are interdependencies which go both ways. So for example, if there is a change in demand in a particular kind of good, then that's going to put pressure or release pressure on parts of the transportation infrastructure. Similarly, if there is an increase in the fuel price, that may increase the cost of manufacturing certain goods. So there are interdependencies within each of these physical infrastructures and also interdependence between the physical infrastructures and the innovation ecosystem. So the innovation ecosystem, as we would all agree here, forms the backbone of the US economy, and it is essential for driving sustainable growth. It brings in the resources that are needed to make upgrades to build the physical infrastructure. And similarly, the physical infrastructure also, the innovation ecosystem relies heavily on these physical infrastructures. If there are disruptions in any one of them, then that may have negative impact on the innovation ecosystem. And as I alluded to a little while earlier, there are three broad kinds of changes we are looking at: the short term, the mid-term, and the long term. And because of these vastly different temporal dimensions to these changes, we also have to think about mitigation mechanisms or resilience mechanisms that operate across the spectrum of these temporal dimensions of changes. So the overarching question is, how do we build in resilience at the design phase, at the time of construction, at the time of operation, and when we have to retire parts of these infrastructures. So resilience then becomes a first order principle rather than an afterthought. So there are three goals that we have in the project. The first one is more of an analytical goal, which is to understand what kinds of interdependencies exist, both within the physical infrastructures and across. The second one is to develop certain mechanisms for imbuing resilience in these infrastructures, and this draws strongly from network modeling and machine learning aspects, whereby these are not just programmed into the infrastructures, but this is something that becomes like an emergent phenomena, and we learn what are the correct resilience mechanisms to imbue in these. And the third one is looking at what kinds of upgrades can be made in order to replan these infrastructures in the face of emerging scenarios. So we are talking about not just designing for resilience, but also bouncing back when things go wrong, as they certainly will. And here again, instead of just a theoretical mechanism of looking at what additional mitigations are possible, we are also looking at the economic drivers as to what are feasible in this space. So the deliverables from this project, there are 5 of them. The network modeling of the critical infrastructures, the online algorithms for planning and responding to disruptions, the integration into a usable modeling and simulation framework, so that's a very concrete software package that's coming out of this work, a failure injection toolkit to play what-if scenarios. What if these kinds of disruptions happen? What about the intensities of these disruptions? And finally, certain policies that can guide us towards sustainable resilience. And in terms of the report card that we have accomplished 3 of these. This is ongoing work, and this one we still have to start on them. With that, I'll conclude. This is our team. Thank you for your attention.
We have time for some questions for Saurabh. Oh, Saurabh?
So most resilience concepts include tipping points and hysteresis. Do you consider those in your models?
Yeah, so that makes this problem quite a bit challenging as well as interesting. This is not a linear system by any means. Up to a certain intensity of the disruption, things may be perfectly fine, and then, as you pointed out, there is a tipping point. So the modeling that we are doing certainly takes into account these kinds of nonlinear discontinuous characteristics, which, as you would realize, is a pretty hard modeling problem whenever you have a discontinuity in there. But that's front and center in our modeling work. Any other questions? Yes.
So how would you deal with issues related to the political decisions on the allocation of resources, financial resources, amongst the network?
Yeah, so that's a good question and something that we don't have a complete handle on. So what I'll give you is a partial answer to this. So our modeling framework models at 3 different levels. There's a technological level, there is a policy level, and there is an economic level. So it's in the policy level, that level where we are capturing some of the political dynamics in there. So for example, if there is an uprising which results in a part of the infrastructure going offline, in our modeling formulation, we can take those nodes offline, or we can reduce the weight that you have on the edges to indicate certain level of disruption. But certainly there is a lot more realism that can be brought into this aspect.
Any other questions for Saurabh? Saurabh, thank you so much.